Welcome to Gurukul Online Learning Network once again, students. I hope everyone is fine. So today I will discuss about the symmetry. In math geometry, it's also very important topics. So in cases of to solve symmetry, we have to think about the two things. Always we need to keep the concept in our mind about the two things. One is line symmetry, another one is rotational symmetry. Okay, so normally we say that symmetry means we make the two parts in equal half. Okay, and today I will also discuss with you about the shape of the diagrams, which is really very important to understand in the basic geometry part. So you see that here I have drawn the isosceles triangle from my first lecture of the triangles. You can come to know about it. Okay, and another one is equilateral triangle, the two sides are equal, and there is given another different type of shape, which is an arrow, and if you have seen this one. So in cases of line symmetry, if I want to make how many line symmetry is here? In this diagram, let me name it A, and this is B, and it is C. So I will go for line symmetry. If I write here line symmetry. So in cases of this diagram, line symmetry, there is only one line I have drawn here, which I make the two equal half. Symmetry means that symmetrical body means two equal half will be in one side. Okay, so if I fold it in another sense, you can understand that only I can draw this line to make equal half, and if I fold it, then it can easily topple over and come to our this side. Okay, and if I topple over that side, then it also comes to this side. So if I fold it, I hope you understand. So this line symmetry means that I have made these things equal half. But if I draw another line from here, say in case, okay, so if I draw a line here, you see that it makes the equal half of the body. Okay, if you fold it, it will come onto these sides, and if I fold from these sides, it will go on that side, isn't it? So by folding, we can place it up to the mark. Okay, so in cases of this triangle, I can draw only one line, but if I draw another line here, vertical line, so you can easily understand it cannot be folded. Okay, so line symmetry will be here only one. But if it comes, if I come to know about the diagram B, which is an equilateral triangle, it means that its all sides are equal. So if I draw a line, vertical line from here, so you see that it makes equal half. It seems to you like the mass of this side and the mass of this side also will be equal, and we can fold it to another one from here to here. And in case of, if I draw another line here, so you see that it makes another two half with the same way. And if I draw another line from here, so it makes also the half with the line. So if I name it line 1, line 2, and line 3, so this 3 line is suggesting that. But in this diagram, if you see, if I name here L1, L2, and if I draw another line from here, L3, by seeing the diagram, you can easily understand that L2 and L3 is not making the body equal half. But here you see L1 is making equal half, L2 is making equal half, and L3 is also making equal half. So if I write here line of symmetry, so I will write here definitely 3. So LS, definitely I'm writing it in a short form, though its full form is line symmetry. But you better, in exam time, you better not write LS, okay? You will gonna write full one. LS means line symmetry, here is 3. So if I come here, so now you see that if I make a line here, if I fold it, it cannot be equal. Why? Because there is mark and the arrow mark, it's not same. If you fold it, it will not come in here. Okay? And if I draw the line here, and if I'm going to fold this, so you see that this side is here, the mark one, the round one, the semicircle, I can say that it's here and it's another part. So if I fold it, it will not come at the top of it. I hope you understand, because this is a bit different diagram I am giving you, because in online lecture, getting very less time to make you understand about the line symmetry. So by these 3 you can easily understand, but this diagram is a bit different. So if I draw a line from here, it will not come equal half, because as you see the diagrams, the drawing is also not the same way. These 2 drawings are same way, but if I make the equal half from here, if I say that the horizontally, then if I topple it over, so this will not come at the top of it. So here it comes, the line symmetry is 0. Now you come about the rotational symmetry, another one. So rotational symmetry, if you try to understand rotational symmetry, it means that you have to rotate the body, and parts of the body will be place it one of the another equally. Okay, so I hope you understand. So you concentrate this one very carefully. So if I'm gonna rotate this, suppose this is a similar triangle, okay, isosceles triangle. Separately I have drawn it to make you understand clearly. Okay, so if you're gonna rotate it, suppose if I'm gonna rotate this side, it will come to this side, but it will not come at the top of it. Why? Because this is a similar isosceles triangle. So in isosceles triangle, two sides are equal, not the third side. So if I rotate it, so this side, if it comes, it will not come to top of it. Okay, and if again I gonna rotate it here, it will also not gonna top of it. So the reason is that again when I can fix it the same place, the way is that if you're gonna rotate it 360 degree, then it will come to its original position only 1. So rotational symmetry will be 1. But in cases of equilateral triangle, if you see that I'm gonna rotate this, then this B can easily comes at C and C can easily comes at D if I name it. Why? Because this is the equilateral triangle. Well, all sides are equal. But in isosceles triangle, it's not happening the same way. If I name it A, B, C, so when A comes to B, it will not come with the same shape. Because why? These two sides are equal. But here the three sides are equal. That's why I can easily place B on C and C on D, or B on D. Again, it comes on B. So one rotation is on C, that is 1. Another rotation is on D, that is 2. Another rotation will be its in original position, that is B, that is 3. So rotational symmetry will be 3. So here you see line symmetry is also 3. Rotational symmetry is also 3. In cases of what? In cases of equilateral triangle. And when you comes up on this diagram, here you can see that in cases of rotational symmetry, RS, I'm writing in a short form as I said it to you again. If you rotate it, so you see that if C comes on D, that's a totally different shape. It will not come here. And if you rotate this one to here, so it's also not coming with the same way as E. See, when it comes in E, it's not at the same way, C and D. And if I name it F, it is also the different shape, isn't it? So rotational symmetry, when it comes to its original shape, when the C will gonna rotate 360 degree and comes on C. Only one rotation is here. So rotational symmetry will be here, 1. So if you come up to know another diagram, like what if I draw it here, suppose what is a rectangle actually, where two opposite sides are equal, rectangle, and if each angle is 90 degree. This is the normal definition of a rectangle. And if you draw a diagonal, you see, what is a diagonal? If I ask you these questions, what is the diagonal? It means that a straight line which is drawn opposite of vertices. Opposite of vertices, that's the vertex, the corner part, the line which touches the opposite of two vertices. So that is called the diagonal. So here actually not mean the concept of the diagonal, but here if I comes up with the line symmetry and rotational symmetry to make to ask you to find it. So here the line symmetry, what? If I draw the line from here, I can easily fold it to the other side. And if I draw another line here, I can easily fold the bottom part to the top part easily. It's gonna fix it up. So, and you can say in another sense, I said you about the equal half. So this is called L1 and L2. These two line is making the equal half. So line symmetry will be here 2. Now, if it comes with the rotational symmetry, so if I'm going to rotate this, so when it comes 90 degree rotation, when I'm going to rotate it 90 degree, it might come here, isn't it? So it will not going to fix it to the other. So if you rotate it 180 degree, that is the total one rotation is 180 degree, then this part will come onto this side. That will be okay. So rotational symmetry is 1, and again more 180 plus 80, 360 degree. So again I will get another one. So here the rotational symmetry for the rectangle is 2. Again I am saying, try to understand it carefully, okay? Listen it carefully. So line 1 when I have drawn, for line symmetry, I can make equal half through L1 and L2. So for rectangle, line symmetry is 2. And rotational symmetry, if I rotate this one as 90 degree, it will not gonna place it at the top, as I said you about the rotational symmetry. So when it will come to this shape, because 90 degree if you rotate, it comes, for understanding you, I'm drawing the rectangle part to make you understand, because this is the 90 degree rotation. So it will not gonna fix it up. So if again I'm gonna rotate more 90 degree, that is 180 degree, then this part will come at the top of this rectangle, fixed it properly. So 180 degree rotation, one rotational symmetry you are getting, another one you are getting on 360 degree. So that's why rotational symmetry is 2. So if I comes, with what a square. What is a square? A square, actually a part of the diagram is that it is all sides are equal and all angles are 90 degree. So what is the difference between a rectangle and a square? In cases of a rectangle, two opposite sides are equal. Here, all sides are equal. So if I'm going to rotate this one, if I find here for this square line symmetry, so this line, if I draw L1, so I can easily make it equal half. Or in another sense, if you fold it, it can easily go to the top of it. And if I draw another line here, L2, I can easily make the rotation. In cases of a square, so line symmetry is 2. But if I ask for rotational symmetry, which will be quite different from rectangle, because rectangle, two opposite sides are equal, isn't it? So if I rotate the square, so you see that if I level this A can easily place at the top of B, and A can easily place on the top of C, and A can easily be placed on the top of D if you rotate it, okay? That is the rotational symmetry. So here the rotational symmetry will be 4. So try to understand, from the rectangle, rotational symmetry is 2, because its two opposite sides are equal. So due to the rotation on 90 degree, it will not gonna come at the fixed position or at the top of the same position, but 180 degree, you can cover it up, okay? And another one will be the rotation on 360 degree. In cases of rectangle, it's a bit different, because its all sides are equal. So if you can rotate A, B, A can be easily placed on B, A can be easily placed on C, A can be easily placed on D if you rotate it. And again, when you give the full rotation, that is 360 degree, again it will come back to its original position. So here the rotational symmetry will be 4. So let me to make you clear, I will gonna make you understand about it, another type of diagram, okay? Okay, student, I hope you understand about the line symmetry and rotational symmetry. I have also explained to you about the diagram, about the rectangle and a square. So rectangle, two opposite sides are equal. In square, four sides are equal. So another diagram, if I want to make you understand, suppose a star diagram, though I am drawing it with a free hand, so it might come accurately, but we are considering accurately here just to ask you to find about the line symmetry. I hope you understand about the rotational symmetry. So I will explain the same way. If I draw a line from here, that is L1, I can make the equal half. So line symmetry from L1, I am getting 1. And if another line I draw L2, I can easily fold it up to that. It's okay. So that will be 2. And another line if I draw here, that is L3, it can easily also can fold onto that. And another line if I draw here, L4, then I can easily fold it to another one at the top, okay? So it means that line symmetry here, it's coming 4. And rotational symmetry, if I name it with A can easily be placed on B, because if you rotate it, A can come to B, and again A can come on C, and again A can come on D, and it can come to itself once again at A. So 4 times I can rotate it. So here it comes rotational symmetry 4. If you come up with a parallelogram, what is a parallelogram? Here you can also easily understand about a parallelogram. Some of the shape in geometry you must try to understand, so that while solving the parallelogram problem or square problem or rhombus problem, I'm coming to discuss with you about the rhombus again. So listen it very carefully. What is a rhombus? What is a parallelogram? So now I'm discussing about a parallelogram. Concentrate on it. Two opposite sides are parallel. It is also known as a quadrilateral. If you write it like this, quadrilateral. Quadrilateral means actually four-sided figure, we can say quadrilateral. Okay? Quadrilateral. It means that four-sided figure we can say. Let me write it for you very clearly. Quadrilateral. Parallelogram actually is on the four sides, and quadrilateral, if I write it Q-U-A-D, quadrilateral, R-I-L-A-T-E-R-A-L, quadrilateral. Okay, so quadrilateral basically we used to say about the four-sided figure like rectangle, square, parallelogram, rhombus. These all are four-sided figure. In one word, we can say these four are quadrilateral. But parallelogram is not similar like rectangle, because in parallelogram there is also four sides. But in cases of rectangle, you see, this is also four side, but here the two opposite sides are equal. In parallelogram, it is also two opposite sides are equal. But though in what sense they are different? Because in rectangle, each angle is 90 degree. But in parallelogram, none of the angle is 90 degree. So if I come up to show an arrow, that these two opposite sides are parallel. So if I'm going to find it out the line symmetry, L1. So if I fold it, now you can easily understand it will not gonna place the things correctly, isn't it? The diagram seems to be like this. But if I'm gonna make a line on a rectangle so that I can easily fold it, but here it's not coming up to the point. So if I fold it, the extra part of this is coming here. So it cannot be line symmetry. L1, I cannot make this. If I make this 2, it's also not going. So for this parallelogram, line symmetry is 0. I hope you understand. And rotational symmetry, if it comes about the rotation matter, so what you will do is that if I'm going to rotate it, suppose 90 degree, it's not coming up to the mark. If I'm coming to place it 180 degree, rotational symmetry, if I rotate it, okay? So this side is coming to this side, and this side is coming to this side. If I'm going to rotate 180 degrees, so it's also not coming there properly. But in cases of rectangle, rotational symmetry in 180 degree and 360 degree is fine. But in parallelogram, I can rotate and place it properly only in 360 degree if I rotate it. In 90 degree, no. 180 degree, no. But in 270 degree, no. 360 degree you can get a rotation. So that is the rotational symmetry is 1 in cases of parallelogram. And if I draw a rhombus, if I can make you understand about the rhombus, what is a rhombus actually? Most of the students of O levels cannot answer this. I don't know why. I am really very much confused about the square. You see, if I draw a little bit like this square, so square, all sides are equal. In rhombus, this is also all sides are equal. Rhombus, it seems to be like parallelogram because their two opposite sides are also parallel. But this is not a parallelogram. Why? Because here all sides are equal. In cases of parallelogram, two sides are equal. In cases of rectangle, two sides are equal. So you see, rhombus, parallelogram, and rectangle, these all are four-sided figure. So what is the difference between a rhombus? Rhombus, what I said, in cases of rhombus, all sides are equal like a square. Okay? But none of the angle is 90 degree like a square. That's the big difference. Here, in square, all angles are 90 degree. But if you come up in cases of rhombus, there is none of the angle is 90 degree. They are parallel to each other. So that's the difference between a square and a rhombus. Okay, rhombus and parallelogram, it's almost the same. If I write here, parallelogram. So you see, in parallelogram, two opposite sides are equal. But in rhombus, all sides are equal. Here, similarity, two opposite sides are parallel. In parallelogram, also two opposite sides are parallel. So to understand this diagram, it's very important because we are coming to know, in a big depth of a geometry part. So some of the shapes I have discussed. Another one, very important shape today I will show you, trapezium. Trapezium, okay? So in cases of trapezium, you have to understand this shape. Most of the students face difficulties where two opposite sides are parallel. Where two opposite sides are parallel, there's another shape, name is trapezium. Another one is kite. So you see, if I draw the diagonals, they are also bisecting each other. If I name them the diagonal D1 and D2. D1 and D2. So these two diagonals are actually bisecting each other at 90 degree. So this is called another shape, name is kite. We're going to solve this kind of problem. In cases of mensuration of different shapes, we're going to solve it. And there is a kite and trapezium, I hope you understand. Rhombus, square, parallelogram, rectangle. These are the shapes you need to know. So these are the basic parts about the rectangle and square. Then I'm coming in cases of parallelogram. Then I'm coming in cases of rhombus. Here now I have shown you trapezium and kite. So in cases of kite, if I ask you to find line symmetry and rotational symmetry, what you will do then? In cases of kite, if you see that line symmetry, if I draw a line here, L1, so you can easily, I can fold it onto that. So this is the line symmetry, it's 1 here. But if I draw another line from here, so you can easily understand this length is a bit shorter compared to the bottom length, isn't it? So if I fold it to the top, it will not gonna fix it properly. So here the line symmetry is only 1. Sorry. And in cases of rotational symmetry, I'm again coming, if I rotate it, okay, if I'm gonna rotate this, so it will not fix it properly here, here or here. Only it will gonna fix it up if I'm gonna rotate it 360 degree. Only one. It means that if I start rotating from this side, it will be placed again here when it comes back. So 360 degree rotation, you can fix it properly. So rotational symmetry also will be 1. But what will be happen in cases of trapezium? That's very important. So if I draw a line from here, L1, so I can fold it on. If the length, two opposite sides are parallel, by seeing this diagram, you can easily understand I can fold onto that, another one, okay? So I can fold it on. So from L1, what will be happen from L2? So line symmetry and rotational symmetry for trapezium, okay? So line symmetry, I'm getting only 1 here. I can fold it to top for this diagram, not for all trapezium. Let me make it very clear to you. Because you can also draw trapezium like this. And if you say that, my sir told me that in trapezium there is a line symmetry 1, then it will be totally wrong. You have to understand you have to first understand the shape of the diagram. So here the shape of the diagram, it seems to me like that. Though it's a trapezium, this is also a trapezium. Because what is a trapezium? Opposite sides are parallel. What is a trapezium? Opposite sides are parallel. Though these two are trapezium, but you see their shapes of the diagram is not same. So trapezium always it cannot give you that. My rectangle you can say that in cases of square you can say that if I write here for this parallelogram this one is actually, and for this one in square if I write line symmetry I can write 2, rotational symmetry 4. I discussed with you like this. So in cases of trapezium, line symmetry will be only 1 in this diagram. But for trapezium, if you draw the line, if you fold it, it will not gonna place it properly. So for this one, line symmetry is 0, totally 0. And for rotational symmetry, if it comes up, that if you rotate it, then the 360 degree back, only it will be 1. In case of this trapezium, line symmetry will be 1. Because the shape is like this, and rotational symmetry, if you rotate it, you will get 1. Only in cases of 360 degree, because this line is too short. So if you rotate it, it will not place it over here properly, fixed it. Here is also not, because this is the longest side. As you see, this is the shortest side, this is the longest side. It will not gonna fix it properly. Only it will gonna fix it once if you rotate it 360 degree. So I hope you understand about the line symmetry and rotational symmetry, about the two things. Today I try my level best to make you understand why it's important, because line symmetry, you know, in graphical problem, we have to find the line symmetry, okay? When I will show you the graphical equations or graphical plotting graphs, okay, you can come to know about it. So I hope you understand about the today's lecture. and it will be fine. And thank you all to enjoy today's lecture. Thank you.